Hi everyone, welcome to bitmachine.co.uk. Today we're going to be looking at how your CPU communicates with RAM to fetch, decode and execute instructions. Now let's imagine that you've switched on your computer, you've opened your favorite spreadsheet application. When you do that, it is loaded into RAM. RAM is volatile primary memory. Primary memory means it communicates directly with the CPU. Volatile means as long as your computer is switched on, the data in RAM will be present. As soon as you lose power, you lose all your data. Now in RAM, when we load an application into RAM, we load an instruction set. Here's an instruction set of 4 instructions. And we load any data related to the application. And as you're typing on your keyboard, lots and lots of data will be being processed in RAM. The CPU relies on a variety of registers in order to operate successfully. A register is simply a little block of memory which stores data. If you are an IB computer science student, studying the 2014 syllabus, you need to understand the purpose of the memory address register and the memory data register. In today's video, we will also be looking at the program counter, the current instruction register, and the accumulator. These are all registers. You also need to understand the purpose of the control unit, which is a very smart component of the CPU, and the arithmetic logic unit, which is another very smart component of the CPU. Okay, let's get started. Every time the clock ticks in your CPU, something happens. So the faster your clock, the speedier the processing will be. So let's tick the clock. We're going to start the fetch cycle. We're going to go straight to the program counter, and we're going to find the address of the next instruction. And if we take a peek into RAM, here is the address. It's address 0. So we're going to be trying to fetch this instruction. So the address of the next instruction is loaded into the memory address register. The purpose of the memory address register is to store the address of the next instruction. Now that we have that address, we're going to jump into RAM, and we're going to grab the data at that address and put it into the memory data register. So the purpose of the memory data register is to store the data located at the address specified by the memory address register. That's the purpose of the memory data register. Now there's a bit more to it than that, and we'll talk about that a little bit later in this video. We've loaded an instruction into the memory data register that will be sent to the current instruction register, because this is an instruction. So it goes to the current instruction register. We've nearly finished the fetch cycle. There's one more thing to do. We need to increment the program counter, because the program counter always references the address of the next instruction. Done. That's the end of the fetch cycle. Now to decode, we're going to take the current instruction and load it into the control unit. The control unit looks at the instruction and tries to decode it. And it says, okay, I need to load whatever is at this memory location. So this is the address of the next instruction. Guess what? It is sent to the memory address register. We go and find that address in RAM. We grab whatever's there, whatever it is, and we send it to, you've got it, the memory data register. Because the memory data register stores the data located at the address specified by the memory address register. Now this time, the data is not an instruction. It's a number. It's just normal data. That is sent to the accumulator. The accumulator is responsible for processing or storing data that is being currently processed. Okay? It's just a register. It's just storing data which is being currently processed. Wow! We have loaded the data at this address into the accumulator. The execute cycle has finished. We're going to go back to fetch. We go to the program counter and send the address of the next instruction to the memory address register. We jump to RAM, grab whatever's there, and send it to the memory data register, because the purpose of the memory data register is to store the data located at the address specified by the memory address register. It's an instruction, so we send it to the current instruction register. We've just fetched an instruction. Before we finish the fetch cycle, we just need to increment the program counter, which will be the address of the next instruction. We're going to decode. The current instruction is sent to the control unit. The purpose of the control unit, of course, is to decode instructions. This time, we didn't talk about this at all yet. This word here is known as an opcode. An opcode. An opcode is like a verb. It's like, this is the thing that I have to do. Okay, so an instruction has an opcode. It also has an operand. The operand is like, the opcode is, this is what I have to do, and the operand is, this is what I have to do it to. Okay, so you can think of it like that. In this case, the control unit looks at this opcode and says, ooh, I have to do some maths. So it sends whatever's in the accumulator into the arithmetic logic unit, because the arithmetic logic unit is responsible for mathematical and logical operations. Okay, so that's done. It now says I need to deal with this next memory address, so that's sent to the memory address register. We jump to RAM, grab whatever's there, and send it to the memory data register. It's a number, not an instruction, so it is sent to the accumulator. The control unit finds that, yes, we got the number that we need. We can now do the addition. So it sends this to the arithmetic logic unit, and the arithmetic logic unit produces a result. There it is. Now that we've got a result, this is sent back to the accumulator, because the accumulator is responsible for storing data that's being currently processed. That's the end of the execute cycle. I think we're about to start the next fetch. Yes, okay. So the address of the next instruction is 2. That's going to be sent to the memory address register. We jump to address 2, store 34. That's loaded into the memory data register. It's an instruction. And that's the end of fetch, but we do need to increment the program counter. And now we're going to decode. Store 34 looks at the accumulator, because this is the data that we're going to store. It's data. We're going to send this somehow to RAM. To do that, we pass it to the memory data register, because this is the register which is communicating directly with RAM. Okay, so it goes to the memory data register. So that's part of store done. We now need to find out where to store. We're storing it at address 34. This is the address of the next address we're going to process, so it jumps to the memory address register. So we know 2 things. We know the address where we're going to store the data, and we know the data that's going to be stored. So this is a little bit more about the memory data register. The memory data register stores data that is located by the address specified by the memory address register. We already know that. But also, the memory data register stores data which is going to be sent to an address specified by the memory address register. Okay? so that it's twofold, it's two-way. The memory data register is storing data which is going to be sent to RAM, and it also stores data which has been retrieved from RAM. Okay, so now that we've got everything in place, we execute that instruction, and that is the end of that execute cycle. We go back to fetch. The address of the next instruction is 3, which is sent to the memory address register. We jump to RAM. We grab whatever's there and get it into the memory data register. That's an instruction. We update the program counter. Now we decode. Hello, control unit. Step in. So it looks at that. It says, okay, I think I have to print whatever's in the accumulator. So it goes to the accumulator and prints. Do you notice that it went through the memory data register to get to the output as well? Okay. Wow. Now take some time to think about what you've seen in today's video, but what we've just seen there is you could think of load as grabbing a piece of data from the keyboard, add grabbing another piece of data from the keyboard, and then processing the addition, and store pushing that data back into RAM and then printing it onto your computer monitor.